My name is Lisa Van Giesen, and I'm the North American Marketing Manager for Tata Technologies, and I'll be hosting our webcast today. Today you're going to hear from a variety of industry experts in the area of manufacturing, operations management, and in particular, manufacturing execution systems. I'd like to jump right in and introduce our presenters, starting with our special guest, Michael McClellan, who is joining us bright and early from the West Coast. Michael is a principal with Collaboration Synergies and a board member of the Manufacturing Enterprise Solutions Association, which is better known as MESA. Michael has over 40 years experience serving and managing manufacturing enterprises. Joining us today from Siemens PLM, we have Andrea Mulas, the MOM Alliances Director for the Americas region, and Andrea Molinari in the role of MOM Alliance Business Development. From Tata Technologies, we have Venki Sundaraj, our Vice President for the Industrial Heavy Machinery Vertical, who also manages our MOM partnership with Siemens PLM, and Hemant Patil, our Center of Excellence Head for MES and MOM, which is part of our Connected Enterprise IT Solutions Group. Just a few housekeeping items before we get started. All attendees are muted and in listen-only mode, so if you have a question, please feel free to type it into the Q&A panel at any time, and we've left 10 minutes at the end of the webcast to answer those questions. Today's session is also being recorded, and we will send out the link to the recording within the next couple of days. So with that, I'll turn it over to Michael.
Good morning, everybody. My name is Michael McClellan, and I'm speaking today on behalf of MESA International. I'm going to give you a quick overview of what MESA is, and I'm also going to describe briefly the major initiative, probably one of two or three major initiatives this year of MESA called Smart Manufacturing, which of course everybody in the world is talking about. As a quick overview, MESA is a nonprofit worldwide organization that brings together people that have an interest in the world of plant information systems. We try to be totally non-commercial. We like the idea and advocate for a peer-to-peer relationship from all of our members, which include vendors, end users, and educational participants. Along with that, we have a global education program that reaches truly global, where we have experts that have put together certified programs, and we deliver those around the world. We believe that we're the strongest voice in this field. At the moment, there are in the neighborhood of 3,000 members within MESA, all with the same set of interest points focusing on the plant floor. Next slide. We are trying, as a central point, to look at what the future is of manufacturing. Everybody wants manufacturing. Every company, every country, everybody thinks manufacturing is great. But the question is kind of where are we going with all of this stuff? And this is from, the statement came from the Smart Manufacturing Working Group. What manufacturers want to do might not have fundamentally changed much in the last 100 years. But the exceptions of what they can do is grow, expectations of what we can do is growing exponentially. We're looking at the idea of a totally connected world that supports the inbound and outbound side of manufacturing. Next slide. The idea of smart manufacturing, and if you're reading anything having to do with economics these days, it seems like everybody is into smart manufacturing. We see this kind of in this form, that there's an umbrella concept of smart manufacturing, which includes a lot of people working on this, all of which are working toward the same objectives. Industry 4.0 in Europe is a big thing. The Smart Factory with the Smart Manufacturing Leadership Coalition is a function that's being sponsored by the U.S. government. And below that, of course, is the Internet of Everything, or the Industrial Internet of Everything. And along with that is the idea of digital manufacturing, excuse me, and digitization across the enterprise. There is a paper put out by MESA called Demystifying Smart Manufacturing. It was published last year. You might find that of interest if you go to the MESA website. The next slide. So just to throw out a couple of what-ifs, the idea of things like can pharmaceutical traceability be delivered to a consumer product group price point? Can we really look at traceability across the entire make-to-buy spectrum? That's the kind of thing we're focusing on. We want full supply chain visibility. We want to be able to look at everything in the supply chain in real time with full visibility from end to end. The Internet, of course, is as equally disruptive in manufacturing as it is in the rest of the world, and we're trying to take advantage of that through data analytics, again, the Internet of Things, and build on a framework that everybody can use. The idea here is in an open multi-vendor framework that we can automatically hook data to and from across the enterprise, regardless of the originating source of equipment or the software applications in place. Next one. Now here's something to think about for a moment. One of my favorite, and I think many people around the world, the favorite things we had, toys we have to play with, is the idea of the cell phone. But the cell phone by itself would be pretty unusable if we did not have all the thousands of applications that people have developed around the world. Well, really, in today's world, the factories we have thousands of applications and thousands of items of data, but we are just now getting to the point where we can figure out ways to get that data into more hands in a more useful form. Next slide. So again, this is pretty much what I just said. I repeated what I just said, but there's so much data exists within not only our plant, but think about the extended enterprise, including all the vendors and all the customers. What we really want to get to is the place where we can make a product that has just been sold. So if Walmart sells a carton of diapers in Idaho, can the plant make another carton of diapers specifically to replace the one that was just sold, to get our supply chain fully in sync from end to end? Next slide. The question here, of course, is not so much data, but the context. How do we use this information in a way that's usable? Going back to the cell phone idea, all those applications would be useless unless they're put in context by the user, combined with a technology that can deliver. So what if this plant sensor data could be combined with context to give exactly true answers to questions that people are dealing with on a minute-by-minute basis across the enterprise? Where is this product? Where in the warehouse is it? Is it in transit? How many did we make today? How many were bad today? How many do we have to make tomorrow? Where all is fine? All those kinds of things that people, not only within the enterprise, but also from our customers' perspective, need to know if we have that information. So the question is, how do we put it in context? And that's where smart manufacturing as a concept is leading us. Next one. So if we can take smart people, add to that smart technology, we have smart manufacturing. This is a pretty simplified view, and if you're from a major company, let's say like Kraft Food, where you've got nearly 100 plants in countries around the world, what are we really talking about? I mean, this is a pretty gargantuan task to say, oh yeah, we can get all that information, put it in context, and just think how much smarter we'll be. Well, obviously that's not something that's going to happen in the next week, but the concepts for building this smart manufacturing capability are well underway. This is a major focus of MESA, and we think that we're leading, we may not be telling everybody what to do, but we're leading in the assembly of information that's being generated on how to do these things. Next slide. So let's assume, since everybody wants to stay in business, that every manufacturer is going to get on board with the idea of smart manufacturing, and I do think everybody eventually will. What do we really have to do this? Well, first of all, we've got to look at the business structure and get the business more in line with what the future holds. And I don't mean build more factories. The idea here is how do we take the existing information, our existing knowledge base, and get that in a form that has broader usage. Build some milestones, establish where you're going to be in the next 2 years, the next 5 years, the next 10 years. Build a different culture. The idea of information being used on the plant floor by people is really not been delivered in the ways that I think is possible. In most cases today, people on the plant floor are putting information in MES systems, in PLM systems for other people to use. And what we want to do is make this a fully conversational exercise with information being supported and delivered to everyone. So look at the skills gap. We all know that older people are retiring, our older employees are going out, and when they go out the door, of course, a lot of the information that we relied on over the years goes with them. So the idea is to build that more into the systems we have. Develop a new vision, get your partners involved, whether they're vendor partners, supplier partners, or customer partners. This is a unified vision that we're looking at. And think about, if you will, for the moment, a value chain that is your suppliers to your end customers working in sync with the same set of information. So with that vision, the idea is to evolve a technology form that will allow you to share that information and keep everybody really on the same page instead of guessing where we are. Next slide. Now, this is kind of the overview of the structure as we see smart manufacturing. The idea of manufacturing enterprise solutions encompasses everything that's going on. This includes, by the way, how the ERP system supports and is supported by manufacturing, PLM, suppliers information. The idea of information is being ubiquitous in its use is the key element here. Whereas today we have many silos that people do not have access to, what we want is everyone to have equal access to it. So when we look at this, we see the overriding crown being the smart manufacturing, operations management, or manufacturing operations management, MOM, MES. All these terms come together in the same environment of how do we support the manufacturing. We see the business value there. We have to provide, we as MESA have to provide education for executives. We believe that all these solutions have to have economic justification. There's no free ride for stuff just because it's smart software. We think there's a very robust commercial marketplace for this kind of activity, and MESA tries to support that in a non-commercial form. We try to build a common vocabulary. Unfortunately, there's, as we all know, in manufacturing particularly, every industry has its own jargon. Every industry has its own way of pretty much saying the same things. We'd like to see more of a common understanding of what's being said. The solution guidance, with our combination of vendors and end users, we look at enterprise interoperability. We don't want to think just manufacturing. It's the enterprise we're talking about. We have a concept of universal metrics. How do we measure this stuff? How do we measure how the plant is doing or how all the plants are doing? Metrics is a large part of the MESA environment. And we look at data hierarchies and application templates in the technical sense. But again, MESA is not a technology enterprise. We think about how we can foster these ideas rather than MESA generating them. And from a practitioner readiness standpoint, we have a lot of vertical specialists. We look at shared ROI knowledge base. We have an extensive paper and an extensive library that covers everything from ROI to applications to how to do things. And essentially, we're all looking for a common way to learn and assess what is going on in this general environment. So the foundation argument here for MESA is education, knowledge sharing, and professional networks. You will not see products that are recommended by MESA. You might see an idea that might be recommended, such as smart manufacturing, but we do not name vendors. We just support an environment and a forum that people can share. MESA International is a safe harbor, non-commercial beacon for those who are interested in this area. Next slide. And there you go. I was on for 20 minutes. That's pretty much what I have. If anyone, we're going to have a session for questions and answers later, and I'll still be on board. Or if you have any other questions regarding MESA, feel free to contact me at any time. So Lisa, I'll turn it back to you.
Thanks so much, Michael. Okay, now we're going to segue into our next section. We'll hear from Venki, who will introduce Tata Technologies and our unique partnership with Siemens PLM.
Good morning. Thank you, Lisa. Good morning to everybody. Tata Technologies is a $420 million enterprise, part of the Tata Group, with over 8,000 plus professionals working in 4 active regions and 15 legal entities. We have over 1,000 man-years of MES implementation experience, specifically talking about MES. We are MES product agnostic, so which also gives us a very strong knowledge base and in terms of the best tools in terms of deployment strategies. And our MES practice has more than 150 specialized resources across the globe. Next slide, Lisa.
Okay.
I will hand it over to Andrea Mullis to talk about the partnership a little bit more and pick it up from there.
Thank you. Yes, thank you, Venki. Andrea Mullis speaking. So yeah, what Venki just said, it's very important. So basically, Siemens PLM, as we will explain later on, in the last couple of years, has developed the strategic business platform, an ecosystem of alliances that we are working with. And Tata Technologies is actually one of the most strategic alliances that Siemens is developing a partnership with as part of a program which is called MEAC, that stands for MOM Expertise Alliance Center. As we will explain later on in the webinar, basically the concept behind MEAC is to jointly develop an MOM practice, leveraging on partners like Tata Technology that has a strong MES and MOM background expertise. They're a subject matter expert. They have the industry domain expertise, as you said, but also they have bandwidth capability, delivery capability, professional services, availability, and bandwidth to support the business moving forward. So, you know, in Siemens as well as other software vendors in the market, they're going to market positioning a unique value proposition around MES and MOM. You will learn more about what's behind our digital enterprise software strategy, product readiness, industry domain expertise, specialization. But specifically around this last point, specialization, it's very important, very key in order to address customer needs and to realize value to customer, to have a strategic alliance in place. It goes above and beyond just having an agreement, but actually means make sure that we support the development of a practice, the partner side, to bring their competencies around a Siemens product portfolio and value proposition up to speed, to make sure that they can fully support what we call the complex selling cycle. In other words, make sure that once we engage with customer, we're able to not just showcase product readiness, which is what Siemens goal is all about, but also make sure that we can successfully respond to customer needs. And this can only be achieved by setting up the expectation and building a strong alliances that really is very much focused in addressing customer expectation, realize value, bring benefits to customers. So the MEAC Alliance Center, I'm responsible for Americas, is a program that's been kicked off here in the US, as I said a couple of years ago. Has now been rolled out to the whole Americas and will be expanded to the rest of the world. Why that? Because Siemens as well as Tata Technology were global players. So we do have a very clear plan, not just for US and for the rest of America, but also for rolling out this program globally. Because at the end of the day, the customer we're working with have both local operation as well as global operation. So it's very important, and you will learn more about what's behind that. But thanks, Venki, and we can move on to the next slide.
Thank you, Andrea. Expanding on the partnership that Andrea had explained in the previous slide, the partnership with Siemens has not just started as a recent partnership. This has been a strategic partnership with Siemens almost for over 20 plus years. Tata Technologies continues to support all of the PLM products associated with NX and Teamcenter and the CAM products from Siemens. And in addition, now connecting and expanding into the MES and the MOM space is only added on additional integration and partnership on the MES and the manufacturing side with the Simatic IT set of tools and supporting the tools in terms of service deployment for Tata Technologies. So if you look at the mission, the primary mission is to accelerate business development and revenue in the area of manufacturing operations management. We have extremely solid capabilities. Siemens brings in all the powerful tools. Tata Technologies brings in its competencies in terms of MES consulting, upgrades, technical support, staffing, platform migrations, and broad-based or the 1,000 plus many years of experience, which we were talking about. And the differentiation is that Tata Technologies can deliver this through this combination of partnership, a very, very seamless integrated approach to delivering MES solutions to our customers, leveraging on our 20-year PLM partnership. And we're also working towards, over time, building up a center of excellence demo center within Tata Technologies, supporting some of the Siemens products within this COE. The next slide, Lisa. So what this partnership really means to you is, as I indicated, Tata Technologies, with its strong position in automotive, aerospace, and industrial heavy machinery industries, and over 25 plus years of successfully being in business globally and working on design, engineering, manufacturing, product lifecycle management, and manufacturing and connected enterprise IT systems. With that kind of a base that Tata Technologies brings to the table, and Siemens bringing in the Simatic IT and the MOM platform, together leads into a strong manufacturing excellence with an increased overall equipment efficiency, lower operating costs, decreasing inventory, more on-time delivery for customers, increased first-time right, higher regulatory compliance, and additional visibility. Next slide, Lisa. So this will be my last slide before we start getting into some of the technical elements. But here, what I wanted to highlight is Tata Technologies has always been very strong in the engineering, design, the digital manufacturing space. And it's now with the MES partnership, we are now able to act as consultants, drawing out MES roadmap for our customers, building up business processes to functional mapping, conducting vendor evaluation, and in terms of execution, application maintenance services to specific turnkey projects, and supporting application and hardware at the plant levels. So clearly, right starting from product all the way through plant floor devices, we have a play in all of these areas with our 8,000 plus strong professionals across the globe. Next slide, Lisa. And now I will transition this over to my colleague, Hemant Patil, who will pick it up from here. Hemant?
Thanks, Venki, and good morning, all. With the background what's said by both Michael, Andrea, and Venki, I would like to talk more about Tata Technologies here on the MES specific area. So as just some time back, Venki has mentioned that we have various tech capabilities as far as MES or MOM is concerned across different domains, which include the automobile, the discrete manufacturing, the process and the component manufacturers, and so on. So our typical solutions, which you can see here, include the solution design and deployment, and the implementation approach is a service-oriented kind of approach. We do our solutioning based on the products of your choice. We do provide the evaluation or the product evaluation benchmarking kind of services for help you to choose the right products for the right application, and then we build the solutions based on those products. So our solutions are generally in modular but comprehensive nature, and we do develop some customized applications also specific to your specific needs of to address certain problems or certain business goals, which are not addressed completely through the core solutions or the standard products. So as far as the solution and rollout is considered, if it's a multi-site rollout kind of situations where you have various plants situated across the globe, we do a kind of pilot building and then do an horizontal rollout to all the plants, selected functionalities which are relevant to the plants, and it's a templatized kind of rollout services. This is more of like our services and our methodology, how we approach in solutioning and deployment of the MES systems. Then when you talk about the MES, the integration with the shop floor and the top floor plays an important role, and that is all where we play an important role here. We do have a lot of expertise on integrating with various shop floor devices, though be it a standard product or a controller or a proprietary system. We do it through the standard products and customized solutions as well. So we write the protocols to get the things integrated so that all the data from your shop floor, which is very valuable, is centralized into a MES database and then can be passed on to the business layer for further analytics and any decision making. So we do have good use cases with the integration of various IT systems as well, the ERPs, which may be SAP or BPCs or any other kind of ERPs. We have the case studies around that, and as I said about the control systems and other integrations. So we do offer business consulting where we do scan your plant or your operations from the MES perspective, and based on your goals of operational excellence on the business goals, we do the maturity assessment through our state-of-the-art tools, and we then present it the gap analysis. We come with the gap analysis to you and then also give you the roadmap on how you can walk the journey of excellence or manufacturing transformation. So in a phased manner or in a big bang manner. So, and we have a kind of unique service model or a very mature kind of service model, which is a mix of on-site and offshore. So that, and we do have quick ramp up and ramp down capabilities to make it more cost-effective services to the customer. So, and we have a very strong services around the analytics, which is talk of the town nowadays. And everybody, when we talk about the smart manufacturing, the analytics plays an important role. For analytics, we do the lot of solutioning based on the manufacturing intelligence, the KPI monitorings, the individual performance monitoring, and so on and so forth. So we'll talk probably more on this when we discuss about the case studies and further slides. So next slide, please. So here I just want to bring you on the same platform. What is an MES? I'm sure you all know it, but it expands as a manufacturing execution system. So when you talk about the manufacturing execution system, it's the production realization part of it, which addresses the production floor, the utilities, the quality, and the material logistics on the shop floor, and then it integrates with your business layers as well. So this is the layer where we help you do the production realizations through various solutions of automation, integration, and probably the trigger-based operations and the alarms management and stuff like that, where you can do quick decision making with the real-time visibility and in a holistic way across the machine. So we help you monitor the performances of the machine at the seconds level or at the minutes level, so that you can take the quick decisions, and it helps you achieve the required agility for any changes, responding to any changes in a proper manner, quick manner. So this is what is a basic understanding of MES. So nowadays it has been evolved into something called as manufacturing operations management. So I would like to highlight the difference here between MES and MOM is that MES is a particularly related or confined only to the manufacturing operations or to the shop floor operations. However, with the capabilities of integrating the MES with other systems at the top layer of business and even at the horizontal layer like supply chain or warehouse management systems, this gives a complete integrated landscape where all the business processes can be managed end to end, and that is where we call it as manufacturing operations management. Next slide, please. So when you call MES digital enterprise, the MES or the MOM really plays a core part, or it's a very essential part, because shop floor is the area where your products are realized, your value is created, business value is being created, and the visibility into your shop floor and the decision-making abilities for right decision-making with the right data, that is what the capabilities are provided by the MES or the MOM systems. So the typical, it also synergizes the operations with the other systems, as I mentioned some time about the ERPs and the PLNs and stuff like that, so that it gives us a collaborative platform to work upon. And the typical modules which MES would have is the planning and scheduling of your production, the quality management, and the real execution of the workflows or the operations, and then trapping the data or getting the data logged for your critical operations or material consumptions, the defects, and so on and so forth, and then giving you the real-time visibility through the SCADA and HMI solutions. So all in all, it gives a uniform platform where you get all the visibility of the data, and decision making is enabled through this layer. So it forms a very core and essential layer for any enterprise which wants to walk on the journey of being a digital enterprise. So next slide, please.
Thanks, Hemant. We're going to continue with you. However, for the audience, I just want to transition over to our customer case studies. We're going to highlight 3 different customer case studies on how Tata Technologies helped deliver value to a variety of organizations. If you want to continue on, Hemant.
Yeah, thanks, Lisa. So before we discuss on the case studies, I would just like to summarize on our offerings or the domains where we operate. So, we totally have an experience of some around 1,000 man years of MES deployment across the domains, and these domains involve the automotive, the steel, the tire manufacturers, the heavy machine engineers, and aeroline and process engineering. So we have done some good end-to-end or complete MES rollouts for automotive and steel companies, and we do have some point solutioning done around the tire and aerospace and process industries. So typical solutions which are part of our MES suite are like the order management, I will just briefly describe these modules as we will be discussing in detail and how they are rolled out in the different customers. So the order management typically connects with the ERP to get the production plan and then tracks it throughout the production floor. Then it gives you the capability of rescheduling, resequencing your orders based on the material shortage or quality defects kind of reasons. And then it gives you the complete production tracking. As I said, it can be your job order, or it can be work order, or it can be a customer order which can be tracked end to end through its life cycle on the shop floor. In the process, it captures the traceability and the product genealogy. It makes a sense to capture this data from the warranty or the quality rejections perspective, so that you can easily quarantine the defective batches or do the better optimum recall management. So we have the solutions around the traceability and product genealogies as well. On the error proofing, this helps in building the first time right kind of solutions or products through the BOM validation and bill of process confirmation, conformance kind of things. So these are the solutions which we are normally deploying in the discrete and aero and automobile industries. Then complemented by this, we do have the performance management solutions where we not only monitor or capture the performance of the machines or critical assets, but we also provide the capabilities of the performance monitoring of the each and every individual operator, the number in terms of its KPI, the operational KPIs, the productivity, quality, defects in his work shift, and we do provide a lot of analysis and reporting around that, so that it gives in insights into the performance of the human resources as well, and form an action plan on his training management. Probably lack of training is resulting in lesser productivity, or there are some maintenance issue with the tools, so which can also come out. And of course the workload balancing. If a certain operator is loaded with more work than the others, then especially in the automated conveyor kind of applications, it affects the overall synchronization. So this kind of visibility and decision-making capabilities are being provided through these layers. And of course the integration part, which we talked about, the IT and the shop floor to top floor connectivity, which forms the basis for business analytics analysis. So next slide, please. Okay, so I'll be taking you through a few case studies, 3 to be very precise, where which are having, first I will discuss about the domain where these are deployed and the business challenges. Then I'll be explaining the functionalities in more graphical way, what are the processes, how the operations are managed or processes are mapped. And then I'll take you to the business benefits which are realized out of deployment of the solutions. So here I start with the industrial machinery company, which is industrial or portable compressor manufacturing company. Now the challenge for this business was they were having a plant which was based on the traditional processes and the older technologies, and they were struggling to have a synchronized synchronized production, so where the all departments and functions operate in tandem to give an optimized output in an optimum way. So there were a lot of operational overheads and the WIP inventory pile of kind of things. So they were really harping on having a lean manufacturing processes setups. So this opportunity was given to Tata Technologies when they were developing or rather setting up a new plant, and they wanted to have the modern kind of capabilities in terms of the lean manufacturing processes. They approached Tata Technologies here. So we studied their existing plant, the processes, and then mapped a complete end-to-end MES journey for them to meet their business objectives, to reduce the WIP, reduce the cycle times, give them the complete visibility into the production flows and operations, and also record the genealogy aspects which we just discussed by integrating the system through ERP. So next slide, please. Okay, so this is a kind of a graphical representation of the solution what we deployed. So if I can divide the complete operations into three major categories. The solution cuts across the logistics warehouse where the incoming parts are being supplied, then there is a production floor, and then there is a finished goods storage. So the MES solution cuts across all these functional areas, and there were modules deployed at the warehouses, third-party warehouses, for supplying the kits required for building the compressors in the just-in-time and just-sequence manner to reduce the WIP or the work-in-process inventory stocks to a drastically lower level which they were having in their traditional way of operating. So typically the ERP system would do the production planning. The MES system would pull that plan and percolate it down to the different machines or work centers, so they get their individual work plans, what is to be done at what time. And at the same time, the MES system gives the triggers on to supply the kits or make the kits required to suit the particular production plan. So the third-party logistics team would kit those parts, components in a particular sequence and deliver it to the shop in just-in-time process, reducing the inventory, as I said. At the same time, the triggers were given to the internal supermarket where they store the common parts or the regular consumable parts, which were also delivered to support the production plan. Throughout the various assembly stations, we had some integrations with the conveyors, the nut runners kind of tools, so that we capture the data for traceability purpose and then do some error proofing operations. We had the workstations or the HMIs for the operator to display critical operations or the SOPs through digital work instructions, where the operator is guided on how a particular operation is to be performed so that he makes lesser mistakes and a complete error proofing is done. In the process, there are some stations where they do the quality inspections through visual inspections and the checklist confirmation. So those things were provided, and those were electronically captured through the MES system centralized database. And as the production goes ahead, if the operators has any requirement on the material or a help call is required, or material shortage is there, or some quality issue is there, he can raise an alert through the end-on systems. After the production, the system goes for the testing, where each and every compressor is tested. There were 30 different parameters which are tested for the compressor. So we interfaced with the customized or the proprietary system test bed machine to get all those 30 parameters, and also the number of passes which it takes for the compressor to before it is finally declared as quality okay. So those kind of traceability records for testing were also centrally stored, and what they call it is a compressor passport was generated in the system and also electronically recorded for future warranty claims and stuff like that. It also generated a digitally signed test certificate after the successful testing of each of the compressor. So all in all the processes were electronically automated, and at the same time the genealogy and traceability data captured for the future analysis. When it comes to the finished good yards, this is where we had done a customized module which had a mapping of their physical layout of the warehouse, and there was a set of rules which is a configurable set of rules where the business can define what compressors can be stored in what possible locations, so that they can segregate the export orders in a particular area, or the heavy compressors cannot be put on the top since it was a multi-stack kind of a rack system. So heavy compressors need not be stored at the top locations. So those kind of rules were defined, and the barcode, on scanning the barcode, the system would automatically decide what type of compressor this is, and accordingly it would give the location where this compressor can be stored. So the 4-click operator would pick up that compressor and put it at the location and complete the operation by scanning the barcode there. So it completes a end positive closed loop kind of system of picking and putting. So it also captured the put away timings and the pickup timings for this complete thing. So in a nutshell, it covered what they were looking for at completing all the business processes in a synchronized way through a single solution. That is what we achieved through this. So next slide, please. So with this kind of solution, which involved a lot of PLCs and different modules like just in time, just in sequence, eCanban, so many things, the ERP integration, the business values which were realized will be were something in the tune of 95% reduction in the WIP inventory. So in their traditional plant, we measured it, in their traditional plant they used to store the inventory to support 72 hours of production. But in this modern plant where we deployed the solutions, they were operating on the stocks of 4 hours only. So that's a drastic saving in the working capital or the work in process inventory. It's not only that, it also provided the 100% visibility into the operations from end to end, so that helped them reduce their meeting timings, and meetings were very conclusive, because in a conventional system everybody used to run with a different snapshot of data and reports, and there would always be conflicts and claims or no, kind of things in the meeting in proving who is right and what is wrong. So this system gave them a single version of truth. So everybody who takes the report would be based on the same snapshot of data or basic data. So there were no more conflicts in this, and it provided a clear visibility for decision making. The productivity also was improved through proper visibility and performance monitoring. So the utilization or the constraints which were there on the shop floor were visible to the ERP systems, to the integrations. So the planning was more perfect in terms of realizing it on the shop floor, the production adherence. So this complete project was deployed in 9 months duration with 6 engineers across different technologies. So with that, we'll walk you through the next case study. Next slide, please. Okay, this case study comes from a discrete manufacturing domain, where it's a leading bearing manufacturer in India having a global footprint. And they are manufacturers of the industrial bearings, and from different kind of bearings, roller bearings, ball bearings, and different stuffs like that. They were challenged mostly on the root cause of the quality rejections which they used to get from their customers, and they were not able to justify or probably come out with the quarantine the exact batch or reach to a root cause analysis what has caused the particular rejection. So it was very clear that they wanted a traceability kind of system, so that to reduce the after sales quality issues and rejections, and better utilization of the existing resources also in the process, and the vendor management processes. Next slide, please. Yeah, so there is a delay, sorry for that. And this slide, this picture depicts what we covered in terms of the traceability. So it again, the traceability was captured from right from the vendor or the supplier of the raw material till the finished good. So the suppliers were deployed, the system module for supplier was designed, and it was deployed at each of these suppliers. There are 100 to the tune of 100 different suppliers with the different share of businesses. They used to supply the raw material, the ball bearings, the grease, the seals, and so many components. So the module would do the barcode printing as per the requirement of the bearing manufacturer, and these barcodes were fixed with the lot size, the manufacturing date, and the vendor code, and the quantity kind of details, and it was fixed on the material which was delivered to the manufacturer. So when the material is received at the raw material store or incoming stores, the operator at the station would have just to capture this QR code or the barcode, and everything will get posted into their system as a incoming stock. After the quality inspection, the same material was delivered to the shop floor with the new barcode being printed, because the quantities and those things will vary because of the lot sizing and rejections kind of stuff. Now this process was further complicated in terms of some material used to come, get processed in the premise, and then go out for further processing to some other vendors and come back in. So tracking that material flow from the plant to the supplier and then getting it in and reconciling on the exact numbers was a challenge which was addressed to the solution. Again, it was a barcoder system which used to track this complete workflow across the process vendors, and the quality records upon receival were also updated in the system through the quality input stations. So at each and every station of operations, the operator was provided with the barcode scanner to scan what batch he is consuming, and then probably update the okay, not okay kind of quantities, so that the batches were divided or split into sub batches, or maybe reduced in quantity from the inputs batch received because of the quality rejections. So all these things were tracked, and the barcodes were generated at intermediate stations to have the complete visibility, the traceability captured through the process. At the end, when the finished goods station, we had an interface with the part marking system, which was a laser system. So the MES system would command that controller to put the laser marking as per the defined process of the customer. So this gave complete genealogy or lot level traceability records created throughout the process, and on top of that we built the two critical reports. One was for the forward traceability, where if you put the vendor code or the hit code or any material lot size, lot code, and it can trace you to the finished good product. So if there is a defect announced by a certain supplier in his batch, then it is easy to trace out the what final products are being made through this material or through this hit code. So they can easily be quarantined. Similarly, there was a backward traceability, where if there is a rejection of the bearing or a lot of bearings from the customer, the batch number or the barcode number can be entered into the system, and the MES system would trace back to all the operations, the operators, the work centers where it was worked, the line, and what time it was worked, what material it constitutes, and who supplied the materials at what time. So that kind of a complete traceability was established to the system, and the customer realized a lot of good benefits out of this, which we'll discuss in the next slide. Next slide, please. Yeah. So before we discuss the benefits, the quick scope is there were more than 20 different touch points, that meaning the operator stations and the vendors and the raw material inside invert stations, and different barcode printers and barcode scanners which were integrated in the system throughout the shop floor. Then there was integration with the SAP system for getting the master data and the production plans, and also posting back the inventory consumption or do the production bookings and the quality defects kind of things. So the typical batch size of production, just to give you the volumes, were around in the tune of 1,500 to 40,000, as you could see here, and we integrated the 100 to the tune of 100 vendors who supply different raw materials, and we did some processing on the raw material outside. And the number of products were 5 major products with 20 different variants. So this obviously met the goal. What business objective was to get an immediate RCA, detail level RCA on the rejected parts, and that is what they could able to achieve through this. So that reduced a lot of cost, which I cannot quantify it here. It's not being, but it's in the tune of 80 to 90%. And then it provided the unit level traceability, as I said. Then it gave the complete MIS reporting and for better usability of the machines and of the operators. And the vendor quality was also improved because with this kind of RCA capabilities, they were able to do the better vendor performance management and performance ratings. So accordingly, the vendors were strengthening their processes to support this quality requirements of the customer. So with that, we come to the end of the second case study. Now I will take you through the next case study, which is from an automobile OEM. So next slide, please. Yeah. So this is UK's largest automotive manufacturing company, which were struggling, or I should say were looking for something which will revamp their landscape. It was because it was running on the legacy platform. There were a lot of applications which were kind of point solutions developed on different technology landscape. So it was a very inorganic kind of landscape, and they were struggling to orchestrate their process in a synchronized manner. So the processes were mapped in and executed in a fragmented manner. So the consolidation or the optimization on the cycle times, the decision making, those things were not happening because of lack of end-to-end visibility and also the traceability of the operations and the parts. So with these objectives, they approached Tata Technologies, and Tata Technologies was chosen through their stringent processes to be their partner for implementing the MES system. So I'll walk you through the what solution implemented there in the next slide. Next slide, please. So the complete landscape had around 1,400 different applications and point solutions which were helping the different business users or departments to carry out different functions. And you can understand when you decide to walk on a journey of a digital enterprise, or agility is an important situation in the competitive environment, and that is where this customer felt a need of having a common platform where this all process orchestration happens in a synchronized manner and gives them the visibility. So we divided the applications into 3 different categories, which some of them were mapped into the SAP, some systems were mapped, some processes mapped into PLM, and of course there were systems or the processes which were mapped, or the functions which were unified through MES solutions on the shop floor. So this was the green part. What you see are the functionalities which were mapped, which involve the production tracking, the order management, the quality bookings, quality management, the error proofing, the part verification, the routing, and so many things. Again, the challenge here in deploying MES was the legacy systems or the old systems on the shop floor in terms of the proprietary controls or the machines which operating mostly in an islanded environment. Though they had the intelligence or maybe the data sending capabilities, they were not integrated on a unified platform. So we deployed a connectivity layer of OPC where we integrated all these machines and systems together and brought the data onto common SCADA platform, which gave them the real-time monitoring and control capabilities of the production across the different shops or the complete value chain, from the weld shop till the final trim and assembly shops, cutting through the paint shop, WBS, and other areas. So the system was deployed for end-to-end operations, and it improved the visibility and decision-making capabilities. It could be controlled through a remote monitoring center or a control center, central control center sitting there. The system used for monitoring not only the tracking but the different kind of events and the alarms, and then record or execute the responses with respect to the events. So that gave them the agility in terms of executing the change management or changing the production plan or doing certain things, material substitutions kind of thing, or changing the routing on the fly for different situations. So next slide, please. So this gave them the capabilities, as I mentioned, on taking the good decisions in right time, as they had the end-to-end visibility of the data, plus it provided the flexibility to the way they operate, and then they were also able to address the build-to-order production scenarios because of the tighter integration between the shop floor and top floor. Any changes to the production plan would be quickly assessed on the shop floor, that how much of this change can be realized or met within the deadlines, kind of compliance kind of thing, and that the confirmation of the change could be easily given in a few seconds or few minutes back to the planning system, so that the right decisions on the committing to the customer of the changed orders could be taken. So these are some of the complexities or the business modalities which they wanted, and the system provided that. So it was a combination of SCADA and MES, as I already explained. So with the system, the kind of benefits which were realized, of course, was the 100% visibility into orders and processes. When I say 100%, it means they had the visibility before, but it was mostly in the fragmented manner. So different systems giving them the different data, and then they had to have manual efforts to combine them together to come out with some value out of it, or some decision-making information out of it. So our system helped them the KPIs coming directly out of the system for quick decision making, and it gave the end-to-end visibility. Then also the quality aspects, there were the records of electronic records of all the defects with the reason codes and the quality indexes stored, so that the analysis and the reports help them to establish the trends, or maybe do the corrective action kappa kind of suggestions coming out of the system. So they could improve on the quality aspects by in the tune of 10% from their existing capabilities. And now, the important aspect is the build to schedule. So when ERP does the planning and the MES layer is integrated tightly with the ERP, and also at the shop floor, you can understand that the production plan, what has been done at the ERP layer, can be easily realized at the shop floor. So this is what another major benefit which they achieved. They could adhere to the planning up to 90%. And some of the 10% could be because of the quality issues or material shortage issue, or some failures, unplanned shutdowns, something like that. So the complexity or the capabilities what this MES solution handles is around 30,000 orders in process across different shops and different facilities of this enterprise, with 4,000 different vehicle bodies categorized as 7 different models across the facilities. And the system gave them the decisions of around 50 million decisions, though it led away on the materials, on the quality and routing change, on the plan changing, the schedule change, so on and so forth kind of things, across the 1,200 different tracking points. That means the critical areas where the particular orders can be tracked or searched throughout the shop floor. And I think this is how it provided the complete value to the customer. I think with that, I end the case study presentation. Any questions you may have can be asked in the last 10-minute session, which we have in common. Thanks.
Okay, thank you. Yeah, thanks a lot, Patim. Well, that shows definitely that Tata Technology has a strong background on MES, MOM, subject matter expert. That is the main reason why we're here together, and why Tata Technology is part of this such a strategic initiative, which is the MOM Expertise Alliance Center. So maybe, Lisa, we can move on to the next slide, actually the following one, because even the next one is a title. Yeah, let's go to the next one. So this is just quickly to recap. Undoubtedly, there are a lot of change in the market space. Each and every single customer is going through a transformation process, and that's the reason why we're here. That's the reason why Siemens has been investing so heavily in the last 15 years to kind of build up a compelling product portfolio and solutions around MES and all across the digital enterprise that you will see in a couple of minutes. So let's move to the next slide. That one of the things I want to highlight, just to, looking at the time left we have, is that you will see that behind our digital enterprise solution, we do have, first of all, it's really cross-industry. So we kind of cover the whole market space from discrete to process industry. And what really make our solution fit into a specific industry is the fact that we have a specific software library that really kind of close the gap between the specific customer requirements, project requirements in a given industry and our standard platform. For that reason, we do have solution for, for example, in the automotive, in the aerospace, in the discrete manufacturing in general, and you will see, all the best practices, use case, references, and you have heard Tata Technology explain their expertise in detail. That will, it will prove, how you can really get value out of a standard platform that is really structured in a way that can accomplish to a very specific industry project requirements. Behind that, it's a scalable, modular, flexible, so you can really start small and kind of expand, supporting the long-term roadmap that a customer may have. So thinking long-term, but acting, and taking tiny steps in order to make sure that the solution really is fully supporting the customer roadmap. So if we move to the next one, the next slide. So of course we're looking at major pillars, the global economy challenges. So reducing time to market, flexibility, increasing quality and efficiencies are these are the major four pillars in the whole strategy, product strategy that we have. So this is important because these are, as the title self-explaining, it says, to stay competitive in this market space, there has to be solutions that are able to address successfully in a very effective way all these very clear challenges. So moving to the next slides. Okay, good. So, of course, those kind of level of speed, flexibility, quality are not achievable by optimizing any single phase of the value chain product. In order for us to excel as a manufacturer, we do have to first digitalize and then integrate any step of the value chain from ideation to product design. So everything digitalized, everything integrated. That's the reason, and that's what stays behind our value proposition. Moving to the next slide. So how did we really get there? So Siemens, and I want to show something which is actually a kind of more internal slides for Siemens, but I think it's important for the audience to understand that, things that just don't happen by chance. Siemens started that journey a while back, and if you look back, back maybe 15 years ago, Siemens started acquiring company. First one was Orsi in the software space, in the MES space, and since then it's been growing both endogenously and exogenously by acquiring a company, bringing on board people, competencies, technologies, and market space, and combining them all together. So the good news here is that the plan that's been nailed down more than 15 years ago is now coming, it's now turning into reality. So in other words, all those competencies, product readiness, subject matter experts, industry domain expertise has now been built up together under one framework, which is our Digital Enterprise Software Suite. It was actually, just for you to know, the company that we belong to, which is Siemens PLM, Product Lifecycle Management, is precisely a company acquired by Siemens back in 2007 that was called UGS. And so now under the umbrella of UGS, Siemens PL today, the whole MOM product portfolio, have a place. And so, as Andrea Molinari, my colleague, will just will take over now, will explain, he will give you an idea, a flavor of what's behind our digital enterprise software product portfolio, and how do we go to market. Andrea, if you want to take over.
Okay, thank you very much. Exactly, talking about what is behind, from a product perspective, this entire strategy. So what is required to realize the digital enterprise? And we need to put together many pieces to realize this digital concept. And in particular, unifying what is the definition of product, so how a product is designed and how it will be manufactured actually, with how a plant can be able to manufacture that product, and of course managing the actual execution of the product. Putting all together those components is exactly the strategy to realize the digital enterprise. Next slide. Okay. Here we see a little more in detail how those components are combined. So the product lifecycle management covers the entire spectrum, and MOM, the manufacturing operation management component, is spanning throughout several areas of the product realization, in particular for the execution of the product. And here is really the key of the digital enterprise realization, so the software component that makes possible the integration of all those aspects. Next slide. And the software suite that Siemens proposed in this field is made up by three major components. So the PLM, the MES, and the automation part, and all of them have to be harmonized to execute each individual task. Next slide. Okay, here we have the various components, and we highlight what we will specifically focus on today. The PLM software product is the component that is dedicated to define how a product will be produced, and with which component, with which ingredients, with which processes, on which equipment, and how it will be possible to plan the production of those products, which raw materials will be required, which components, how early they have to be acquired, the lead time of the product, so how you size the manufacturing plant and so on, which is a big piece of science. And on the other side, we have the execution of the production, in particular the automation, so with the equipment that make sure that the operation are executed as required in safety conditions. And in the middle, there is a coordination of all those aspects. So knowing how a product has to be produced and knowing what each plant can deliver, put everything together and produce what is required with the right quality, in the right time, possibly informing all the various stakeholders of what is going on in the production side. Next slide. So all of this is called MOM. So we start to really focus on how the software suite for MOM is composed. There are a few components that takes care of various aspects. And here they are listed. So the SCADA part and the, let me say, the automation part, which is the basic to handle physically the plants and the shop floor automation. Then there is the MES part, which is Semantic IT, the name of the component. Semantic IT is providing the execution use cases, basically. So integration with the ERP to know what has been sold, what has to be produced, integration with the PLM to know how it has to be produced, integration with the shop floor to know what is available for the production, and the execution of all the various processes to accomplish the required production. Then the quality system, the QMS, quality management system, to follow the entire quality process, even outside the pure MOM space, but in particular during the execution, applying the various processes, applying SPC, and making sure that the product is produced with the right quality. Then the advanced planning system. Advanced planning is taking care of transforming the long-term, the medium long-term production schedule into an executable medium short-term schedule for the plant. So knowing what is your production has to be in the next 3 months, as usually an ERP defines, the APS is taking care of defining the daily operation in each plant to accomplish the required production. And then another component that is, again, in the execution, it's called CAMSTAR, and is providing the use cases for a particular type of production execution, which is in the medical devices, that is combining the complexity of the repetitive assembly in discrete manufacturing with the regulatory compliance typical of the pharmaceutical industry. Next slide. And how all this is put together, there is basically an entire infrastructure to manage all those components together. We call it the manufacturing operation backbone. Is a software layer that harmonizes all the functionality provided by the various components that we have very quickly seen them in the previous slides, all together to provide each one its own value to the execution of the production. You may notice on the left side of the slide that the integration with the Team Center, which is the PLM product from Siemens. So there is a direct and closed loop integration with the PLM system. So the bill of material, the bill of processes, all the information necessary to understand how to produce a product are automatically integrated among the various components. And so the manufacturing execution system knows already how a product has to be produced, on what equipment, with what materials, and so on. So it's directly integrated. Here, very interesting, the fact that, as you can see, there is a backbone, a unified backbone, and a verticalization for industry. As we have seen, the MES from Siemens is cross-industry, and the ability to be applied in every industry is provided by the verticalization of the platform, with the use cases of specific industry, in particular in the discrete manufacturing, automotive, mechanical and electromechanical assembly, also known as mechatronic, and assembly and complex manufacturing, typical of the aerospace industry, for example. And on the other side, the industries that are not assembly, but typically have a batch area of transformation of ingredient and a packaging area. And in this field, there is the food and beverage, the CPG, tobacco industry, and so on, and the chemical industry as well. And the life science, who is a dedicated field because of the regulatory requirements that are extremely complex. Next slide. Here we see in a nutshell the various functionality of an MOM system. So really we are entering into the capabilities of the product. So we see an integration with business and engineering system. With a business system, usually is an ERP. With engineering system, in the Siemens PLM value proposition, the integration is native with the product. Below, a shop floor integration with the shop floor devices that can be PLCs, DCS, batch systems, and so on. Also in this case, the system is open. In the case the shop floor devices are Siemens, there are some benefits out of the architecture. In the middle, the various components, the production scheduling, the data collection and operator guidance through electronic work instructions, the execution of the quality procedures in runtime, logistic management that is not warehouse management, but is the ability to manage the flow of the materials throughout the plant and knowing the working process and knowing what is where, managing the intermediate buffers and so on. Of course, the tracking and tracing, the genealogy, and the line monitoring system to define the performance of a plant. Now we can go a little more in detail in each component, so we go to the next slide, but very quickly a quick introduction to each component. So the planning and scheduling, as we're seeing, is the component that receives from the ERP the massive long-term scheduling and transform it into an executable schedule on the plant, on the various lines, and optimizing the production according to algorithm that can be configured. The benefits are obvious in this case, and really in some cases there are double-digit improvement in standard metrics. Next slide. In the pure execution, providing that the advanced planning and scheduling is providing what has to be produced, now we have to produce it. So in particular for the assembly and complex manufacturing, we are talking about all the use cases that helps operators to run the production in a environment where there is relatively small volumes and relatively high variance. Typical example on one extreme is the aerospace industry, where the volume usually is 1 unit. When you produce an aircraft, is your batch of production for that case. And a very high variance because there are no pieces that are the same. So here is important really the electronic work instructions, so how you guide the operators, and the integration with the PLM system for the engineering, so for escalation, for non-conformances, and so on. Next slide. This is the mechatronics, so the repetitive assembly. In this case, we are on the other side. Very, very high volume and low, if no variance. In this case, attention is on the reporting, a line monitoring system, interlocking, and so on. Next slide. Quality execution, and we have seen the ability to monitor the non-conformance, the rework, running statistical charts for statistical process control, defect tracking and traceability, and so on. So this is typical functionality for quality management. Next slide. And this is a summary of the MOM with the major functionality. If any of you is familiar with ISA 95, can find this slide very clear. Next one. And this is how Siemens addresses the vision of the Industry 4.0 through the collaboration platform based on the Digital Enterprise Software Suite. Next and final slide.
Thank you, Andrea. Just to wrap up with this slide, 1,000 plus man-years of experience, 150 plus MES engineers, 25 plus years in business for Tata Technologies, coupled with the 20 plus year partnership with Siemens, strong products that Siemens offers in this space, coupled with all of the consulting knowledge and experience from Tata Technologies. I think our organizations now are ready to bring this partnership to our customer base in a more synergistic manner to help bring this value to our customers across the globe. With that, we're now ready for questions. Lisa?
Yep, thanks. We have just a couple minutes left. I want to thank all of our panelists for their time today. Attendees, if you have a question, please feel free to enter that in the Q&A panel. And I'll wait just a few seconds for those to come in. I do have one from earlier. This one can be addressed by Michael. We have a question about MESA membership. Are the members mostly vendors or individuals, and what type of people or companies are typically MESA members?
That's a good question. It's really quite a broad array of people. We have, I'll just mention some of the original software vendors, which include Siemens, but we have many service providers as vendors. Siemens, Tata has been a member for a long time, so it's companies of this type. On the user side, just to mention a few, certainly Mondelez is one of our bigger hitters. Boeing has been a member for a long time. Many major companies are participating in MESA, either as a company or in some cases as just an individual. I recommend going to the MESA website. It's mesa.org. And look under membership, and you can get an excellent insight into what the there are no requirements really. It's just fairly inexpensive to join, and we welcome anybody and everybody who has an interest in this area.
Okay, great. Thank you. Another question's come in, and I'll turn this one over to the Siemens team to answer. How relevant and strategic is the closed-loop integration between MES and PLM?
Oh, okay. Thank you. Very good question. Is extremely strategic because it's addressing one of the big issues of the manufacturing in the complex manufacturing. Basically, it's when from the plant shop floor there is a non-conformance, and there is the need of escalating back to the engineering department. With the closed loop, basically, we have experienced reduction of the time to do those operations from the range of weeks to the range of hours. So you can imagine how you can quickly speed up the production and reduce the waste time in case of non-conformances.
Okay, great. Thank you. Okay, well, those are the two questions that have come in, and we are just about at 11:31 here, so just 1 minute over. So great job, everyone. I want to thank everyone for joining us today. And as I mentioned, this session has been recorded, and we will send out the link within the next day or two to that recording. Thank you very much, and until next time, have a great day.